Well, welcome, Diraj, a new volunteer. Greetings. Welcome to our weekly projects meeting. And what we usually do is we have a round table. We go around whoever's here or whoever has submitted reports. And what we do is we talk about what we've done over the past week, what we have planned over the next week. If we have any roadblocks, anything that's blocking our way, problem that we need help with, and if we need any resources that ORI can provide. So that's the basic format of this meeting. And then sometimes we'll then go into like office hours or just general informal discussion. People can bring presentations or PowerPoints if they want to, or show on the camera what they're up to. And then sometimes there's other meetings throughout the week. This one we try to keep reliably up and running and recorded and posted so that people can see kind of how we get work done and what people are up to and what they need help with. So why don't you tell us a little bit about yourself, whatever you're comfortable sharing, and then what so far out of what you've seen, what we do, what you're most interested in learning about, contributing towards, or bringing on.
So, hi all. Super happy to be joining this organization. Uh, I'm from Medalia, mostly working as a Java backend developer and have solid experience in. I'm a senior software engineer in Medalia, working mostly with backend application. Prior to this, I also have some scripting experience with some language like Python, Node.js, which I think can be helpful for the job all. Uh, Apart from this, I'm from India. It's 12:30 p.m. now. Uh, so that's all I think. Let me know if I can be helpful in any way.
Wow. Well, thank you very much for joining us. Deeply appreciated. And yes, we rely pretty heavily on Python, and we have a number of projects that are Python, either straightforward Python script. Right now, the transmitter program for Opulent Voice is in Python, implementations in Python, along with the independently developed receiver. Another major bunch of Python work is in the Earth, Venus, Earth link budget and link analysis. And so we use Python notebook, or sorry, Python lab to get that done. So there's plenty that we're very comfortable with Python and use it. So there's lots that could use another set of eyes, some more contribution, or some guidance from an experienced Python practitioner. So thank you so much for joining us. All right, and greetings to Evan.
My
Hi.
pleasure.
Oh,
Oh,
hi. Thanks
sorry,
for.
didn't mean to interrupt. Sorry, Jiraj, did you have something else to add? I'm so sorry for cutting you off.
No, nothing. That's all. Um, I'll fulfilling these Python projects.
And then, yes, plenty of digital signal processing, protocol development, algorithms. So anything that you want to learn or do more of that you may not get an opportunity to do in your day to day, we're here to help you achieve those goals. That's what we really like for people to have some professional, personal development with open source work. So thank you. All right, greetings, Evan. I think we've met before, and very good to see you again. I think that you're a regular contributor to DSES, if I'm not mistaken.
Um, well, thanks for having me back here again. Um, I built the Bitbanger radio. That's kind of what brought me into the group,
Oh, very good.
and I'm excited just to be here. The projects you have are really interesting. Kind of above my head a little bit, which is good.
Awesome. Well, thank you so much. And we really appreciate you participating in RF Bitbanger. And there should be some news there. We have a very interested, good kit builder and kit practitioner who's interested in spreading the word a little bit more for us. So we'll be closing the loop on that and trying to get more of the word out and get more of those kits out in the world.
Oh, that's great. I'll try to look for that link.
You
Uh,
bet.
I, I'm going to the Sussex Hamfest here in New Jersey this weekend. I had hoped to have kits for sale just because they're such great kits, but maybe next year.
Yeah, we have them for sale on eBay, and there's plenty. So why don't I, after this meeting, why don't I get in touch with you and let you know how to spread the word?
Okay, great. That'd be perfect.
Yeah, thank you so much.
You're welcome.
All right. And then let's see, Paul, you want to tell us anything that is going on with the lab, with Remote Lab West or South equipment, and anything that you've seen over the past week that needs attention or anything that needs upgraded?
Okay, well, it's going to be a short report because I don't think there's anything new with either lab. The the equipment recovered from Remote Lab South is not currently powered on, so it has not generated any new problem reports. Um, and I haven't made any progress on the speed improvements front that I wanted to use it for. In fact, I haven't made any progress at all on anything this week except for talking over some issues on how to handle the different modes of Opulent Voice encapsulation. So.
Yeah, I think that's where we've been spending a lot of our time is on getting Opulent Voice protocol development further down the road. So there's a progress report. There's an article on our website, and it'll be in the newsletter, which is going out, the June newsletter. So kind of we publish at the end of the month. We publish the previous month's work. So there's a big update on the Opulent Voice work and a description of like where you find the source code and what decisions were made, what roadblocks were encountered, and some of which were overcome. So there has been a lot of progress there. The things that we're talking about for the next steps are a differentiation between if you are talking directly to a radio. So this is our uplink protocol for either terrestrial or space work. So this is the uplink from you to the central node, to the satellite, or to the repeater, or to just another station from point to point link. And when we are talking directly to a radio, this code is running on a Raspberry Pi, so it's essentially the human radio interface, and it's running a script that gathers your voice, turns your voice into digital voice Opus packets. It gathers your keyboard input, so you can chat away on a keyboard, and it interweaves that with voice in a way that does not bother your voice. And you also have a data channel, so you can have data packets that go if you want to transfer a file or something like that. There's also control packets, which handle authentication, authorization, all of that control stuff. And so when we make these frames and we send them out and we figure out, what frame does what, your voice has precedence. So anytime you're talking, because we don't tolerate delays in voice very well, then that takes over the channel. And then the other things like chat and data and control messages are worked out. There's a little priority queue in there. So when we frame these up, and we usually think of them as going directly to a radio. So they go directly to a software-defined radio. Usually in our first implementation, it's going to be a Pluto SDR, but it could be any radio that has an Ethernet port. So out on Ethernet go the prepared frames, and in the frames go to the radio. So when we're doing that, we don't really have to worry about the frames getting out of order because they're just going down an Ethernet cable, usually. But since this is a sort of a software package that could be used over the internet for internet chat or to another computer, and then to a radio, you can think of it pretty much any complicated system you like, really, with communications these days. If you have a software-defined radio, your radio is very remote from your, essentially your input device that you're talking to with your microphone and your speaker and your keyboard and a display. You can see that, over the longer link, the packets might get out of order because that's just the way that the internet works. And so what we're talking about for this next week is to handle those two cases. If you're talking directly to a radio down a wire, you don't need TCP or transmission control protocol. But if you're talking to an internet repeater, if you're talking just over the internet or you have a large internet component or some sort of more complicated networking situation, a remote radio, for instance, you may get that packets out of order. That's why we have things like TCP. So in our configuration file, today, we have a difference. We have a configuration item that says, okay, you're talking to a computer or you're talking to a modem. You're talking to a modem, that's right there. That's right there, your radio. Don't have to worry about things being out of order. Don't have to add extra protocol. If you're talking to a computer, like on the internet or a remote system, then yeah, you might. And so over the next week, we're going to sort this out, test it, make sure we're not adding anything extra to the code that we don't need. And so those are one of the things that's captured in the issue tracker on GitHub. So that's where we're at.
I tried to write all that stuff down concisely last night. And as what usually happens when you try to write something down in detail, you discover it's a little more complicated than you thought it was. And so I think I put it aside. I had to get some sleep instead. But I'll pick that up soon and try to write some more. I think what I discovered is that if you have a remote modem that's on the other side of the internet, you probably need it needs a computer to babysit it. So it might as well be exactly the same modem with the same local oriented interface. And if you're going to pipeline it over the internet, then you just put another copy of Interlocutor running in a mode where it doesn't do most of the fancy stuff, but does handle the interfaces in order to take care of the encapsulation. So we don't want that complexity in the modem. So it's going to need a babysitter to help it.
Okay. That makes sense. I think that's how a lot of people handle like their flex radios is they have a computer at the site. So at your remote station, you have a computer that's handling the radio and you talk to the computer. You don't try to talk directly to the radio. Some of us do and get interesting results with delay and all sorts of neat things. So that's a good point. So yeah, please, everybody look to the issue tracker for the interlocutor and postlocutor repositories. And if you see something that you got some good advice for us about how to handle networking, remote operations, and accessibility, please weigh in because we would really appreciate the extra contributions and review and opinions. They're important to us. We want to make a really good radio, not radio interface for humans that just works and is a delight to use. That's the goal.
What project is this?
Oh, this is for Opulent Voice, which is our uplink protocol for their satellite, amateur satellite system.
Very interesting. Thank you.
Well, sure. Yeah, the major benefit of this particular uplink is the high quality of the voice. When we looked at all of the other amateur and public service modes, they all tend to use the AMBE, AMBE codec, or rough equivalent like the CODEC 2 codec, which is an open source codec. So AMBE is closed or proprietary, CODEC 2 open. But all of them are low bit rate. So we're talking 3,400 to 3,600 bits per second. And the major complaint about that bit rate is that it is just not that good sounding. It's harsh and fatiguing to listen to. You can take a short burst of it, like a check-in on a net is not a problem. But if you have to have a conversation, it's just the quality is just not that great. And so we said to ourselves just a couple of years ago, we're like, well, we could stand to have a better quality voice in amateur radio, digital voice. And so why don't we use a higher bit rate? The compromise that you have is that a higher bit rate is a wider bandwidth signal. And it turns out that we just have to give up at this point with the current regulations, at least in the United States and in most countries, you just have to give up VHF. So if you don't mind giving up VHF and you want to be legal at UHF and above, then you can have a big increase in voice quality with a higher bit rate codec. Bit rate is the number of bits per second, that you are encoding. And it's roughly equivalent to displacement in an engine. So if you have a large capacity engine in a car, big displacement, you get more horsepower. If you have a small engine, less horsepower. Same basic idea for codecs. You can do some fancy math techniques to make a low bitrate codec sound a little better, but it's never really going to achieve the same level of quality as a higher bitrate codec. So we use 16,000 bits per second Opus codec. We could use a higher bitrate, but we think 16 kilobits per second is a real good sweet spot. It sounds amazing. And I think Paul said something. Oh, he put a link. It's more a link to so YouTube, more about good voice quality. So if you'd like to follow up on this, then please click the link and check it out.
Oh, thank you.
Oh, sure. Yeah, this was just we were motivated to do a better job in terms of the voice quality. The second thing that kind of differentiates Opulent Voice is that it combines data and keyboard chat and the control overhead messages all in one channel seamlessly. So you don't have to switch to a second packet mode. If you're familiar with digital voice products, some of the time you have to actually switch modes to send data or, to handle things like keyboard chat or send a file.
Right.
And with Opulent Voice, you don't have to. It all gets sent out and it's prioritized and it doesn't interrupt you. You don't have to switch modes. It just handles it. So we thought those two things were worth our time. And that's our native digital uplink for our satellite or terrestrial repeater project. So this would go, this works for the Earth as well as for space. Okay, let's see what else has gone on over the past week, Paul. There's some other stuff that's happened. Pete published his article about delay Doppler channels, which is we're all learning about delay Doppler, and that's out. That's on our website. It'll also be in the newsletter, so you can check it out. It's a very nice PDF that he did, and he gives the MATLAB examples and talks. Part one was last month, so you can find both part one and part two. So he gives a good mathematical introduction in part one of what a delay Doppler channel is. So if you're familiar with OFDM, orthogonal frequency division multiplexing, delay Doppler is similar to OFDM, with a couple of interesting twists that make it even more efficient than OFDM. So it's all new stuff to us, and we're learning, and Pete's taken the lead on that and kind of laying out the explanation. These delay Doppler channels, we investigated them in order to help out with Earth, Moon, Earth, and Earth, Venus, Earth communications attempts. We in the amateur community, we have an active community of people that bounce signals off the moon and get them back and are able to communicate by this channel. It's really pretty fun, and it's hard. It's a technical challenge. So the amateur community, one of the leaders of this is DSES, or Deep Space Exploration Society, and Rick is a member of the board of DSES. They said, why don't we try to do the same thing with Venus when it comes close to us, which is every 18 months or so. It gets pretty close to us in the orbit. So the attempts were made. And so far, we've been able to bounce a radar signal, like a carrier signal, off of Venus. The next step is to try to actually get information. So this is a harder challenge. So instead of just a tone being sent out, it's actual modulated signals. And so that the investigation for delay Doppler channels is part of that effort to try to be ready for the next time. The next time that we're going to attempt these communications will be in October of 2026. So we're all working hard on that, getting ready for it. And there will be places all over the world, citizen science and amateur astronomy and amateur radio sites with big dishes and lots of power. So places all over the world will be participating in this. It'll be very exciting, and we'll be better prepared in October of 2026 for attempting some actual communications. So that over the past week or so, Pete published his part two, and for the next article, it will shift into even more practical concerns. That was his plan. About what does all this math mean in practical terms? Like, does it really help us? Early indications are that the channel from Earth to Venus and back, that we don't have enough information about how the channel changes. So if we figure out that the channel is stable enough to take advantage of the things that we know about it, then this is a good modulation. And if the answer is no, well, then it still will work for EME, but too long to Venus and back. So over the next week or so or month, weeks to months, we'll get some more answers on that. All right. Did I miss anything? Anybody have any other questions or comments or anything that they would like to bring up? Let's see. I have one other news item that I thought was interesting. It's in our there's an interesting polarization issue on it's a very popular microwave radio. We do a lot of microwave amateur communications. Almost all of what we do at ORI is designed for microwave. The company called ICOM has a IC 905 radio, or we call it the 905. It's a 10 gigahertz radio, which is somewhat rare for commercial radios. For 10 gigahertz band, most hams build their own rigs, or buy them from very small volume manufacturers. And so ICOM has this is a recent radio, 10 gigahertz. And there was an interesting thing that happened. The polarization, the dish antenna, so it comes with a dish antenna. It comes configured for vertical polarization, which is standard in Japan, where ICOM is located. However, in the United States, most US amateur microwave people use horizontal. And if you mismatch your polarization by 90 degrees, it's a pretty big signal strength difference. And so there wasn't any documentation about this. People kind of just figured it out. And ICOM has been very responsive, and they're changing the documentation and reaching out and making sure that people know that their radio is not broken, that the dish just happens to have a 90-degree polarization issue. So this was something that SBMS was involved with, and successful communications back to the company. But interesting things like that happen in radio. You can see that there's pretty big regional differences in how we do things. You see the same or similar thing with commercial standards or even band plans. What we have for the ISM bands here in the United States is not the same as in India and not the same as in Europe. So when you make a product for industrial science or medical band, you really have to be aware that the target frequency may be completely different. And this really affects satellites as well. So if you don't have a allocation or a band that is worldwide, then your satellite mission is a lot more complicated. So these are things that we have to deal with in the community. All right, any other questions or comments before we close? Okay, well, thank you so much, everybody, for your time and attention and all of the wonderful talents and projects and things that are going on. One of our next big events for the year is coming up. So we're talking about DEF CON. It's a large hacker conference in Las Vegas, and we usually have an open source digital radio exhibit in the RF or radio frequency village. And it looks like we're welcome to come back once again, which is great. A very supportive team of people in the village. And that's where we are able to do demonstrations to people that are very enthusiastic about open source digital radio work. So more about that very soon. We have we will be representing ORI at the FCC Technological Advisory Council meeting in early August. It's the last one for this 2-year term. And so I'm looking forward to that. We've been working on some recommendations and helping the working group in advanced spectrum sharing. So that's been our major contribution over the past year, along with some 6G contributions. And then looking a little bit further ahead, we'll be in Germany to represent ORI and bring our work to AMSAT DL and the ESA, the European Space Agency. There's a workshop later in September of 2025. So those are the big events and some travel coming up, and we're hoping to bring back a lot of good news and be able to share what we do. And if anyone's interested in helping support any of that, please get in touch. And then after this meeting, I'll get in touch with you, Evan, to talk about how to support the outreach for RF Bitbanger at the upcoming event where you're at.
Thank you so much.
Yeah, sure thing. All right, everybody. We'll see you next week and see you on Slack.